Hi, I'm Scott Bland with the Technical Training Organization at Texas Instruments. What I'd like to do today is show you how to set up and use the Z-Accel sample application running on the EZ430 RF2480 target system. You can see to my right here that I have the IAR embedded workbench running. I already have the Z-Accel project loaded. I'm going to build and download the project to the last of the boards. I've already done it to the other two boards. You can see that it's downloading the application right now. And I'm going to go ahead and run that application on that board. Now we'll switch over and take a look at what's going on the boards themselves.
To make it so that I don't break the emulator board on this side, I've attached everything to a USB extender cable. This portion here is the emulator, while this is the target side over here. The top part here's the MSP430. If you look on the other side, the CC2480 is right here. I don't know if you can see it, but the red and green lights are blinking here, and the push button is right here. There's also a photo sensor right here and a chip antenna. All three boards are running exactly the same software. Their functionality is only changed by the pressing of the switch. Now, I'm going to press this button right here once, and the board is going to go through a sensing to see if there's any other networks out there, and it's going to act as a coordinator. And in just a moment, the red light comes on. Hopefully you can see it. This red LED is on, indicating it's the coordinator. So I'm going to place that right there where coordinator is. So I'm going to take one of the other boards right now. This is just one of the other boards, and I'm going to power it by connecting the jumper. Board is in the exact same place. Both LEDs are blinking. And now I'm going to press the button on the board again once. Now it will detect the coordinator, and it will set itself up as the router. And I don't know if you can see, but the green LED is lit right here, indicating that it's the router. Finally, I'm going to take this device. This will be the end device. Within a 2-second window, I need to press the button on here twice. So I'm going to press. It'll take it a few seconds. Now both LEDs are blinking slowly, indicating that the device is sending data out and that it's getting acknowledgments. And I'll put that down here. Let's take a look at what that would look like on the wireless sensor GUI. So let's take a look what the startup process would look like on the EZ430 RF2480 sensor monitor. I've already started the software running on the board I'm going to use as the coordinator, and now I'm going to reach over and press the button once, configuring it as a coordinator. Both the other boards are currently off. So you can see that the board is connected and reading, and it's indicating that it's a sync receive. That's the Z-Accel term for a full function device that's receiving data. So I'm going to take the router, and I'm going to power it up, the board that I'm going to use as the router. And now I'm pressing the button on that one to configure it as a router. The light has turned green, and now you can see that it's reporting the temperature of the internal sensor on the MSP430, the short address 0x0001, the time that it was received, the last data packet was received by the PC, and then the battery voltage down at the bottom. You'll notice that the temperature, this is in my my office here, it's not 28 degrees C. The temperature sensor on the MSP430 has not been calibrated, so the temperature is incorrect, but it's data that's being sent nonetheless. Alright, I'm going to power up the last board, the end device. Alright. You can see that that one's reporting 31 degrees, that its short address is 0x796F, the time, and its battery voltage. Of course, again, the temperature sensor isn't calibrated, so the actual value isn't really that important. You'll notice, of course, that both the router and the end device are connected to the coordinator. This will be the case until the coordinator fills up and is unable to take any more children. At that point, you would have children off the router, or if the router were the children of the router were out of radio range of the coordinator. So this is fully expected, and those addresses of 1 for the router, that's the first router attached to the coordinator or sync, and then the source device, the end device there, that one as 796F, that's the expected short address of the first end device that's connected to the coordinator or the sync.
Now let's go through the same procedure to take a look at what's actually being transmitted over the air with the TI packet sniffer.
I'll be using this SmartRF04 EV board as my sniffer, along with this CC2430 evaluation module that's plugged into it. This 2430 EM board, this radio is an 802.15.4 radio, completely capable of receiving all of the ZigBee packets that are being sent out by the Z-Accel radio. Here's the antenna for it right here. All of those pieces of information will be sent via the USB port to the computer and displayed with the sniffer software. Alright, so I've started the TI packet sniffer software, and we can see that I've set the channel to channel 11, the channel that I'm operating on. The display area here will display all the packets received at that frequency once I click the capture button. Okay. So I'm going to go over to the board that I've designated as a coordinator and press the button on it once. We should see a series of beacon requests as the device tries to figure out if there are any other networks operating on the allowed channel, in this case channel 11. When it does a series of those, it will illuminate the red LED indicating that it's the coordinator. It cannot find any other networks. So now I'm going to power up the device I've designated as the router, and I'm going to press the button on it once to indicate that that's the router. After a few seconds, the green LED comes on. I don't know if you can see it here, but there's the green LED. And we'll slide the window down to see if it's achieved a short address. Here's the short address status right here. We can see it's got 001. That designates that it is the router. It's exchanging payloads and acknowledgments back and forth with a series of messages. Now we'll go ahead and try to get the end device to join up. I'll power that device up. Press the button twice. After a few moments, we should see the LEDs here just start to flash. Now they're flashing. Alright. I will stop the packet sniffer from receiving, from capturing, and slide down. There's a lot of messages, beacon request, an association request from the new device, the end device, and then a short address association status. Here's the 796F. Here's where the coordinator is responding with the new short address for the end device.
Thanks for watching. I hope this helps you understand a little bit about what the Z-Accel sample application does and how it works on the EZ430RF2480. Thank you.